Hello everyone. We are back. We are back to chapter 5 and we're going to start today. We're going to do section 5.3 on Venn diagrams and set operations. So I have two definitions here for you. So we have, what is a Venn diagram? A Venn diagram is a diagram that uses circles to represent sets and their relationships. And the universal set is a collection of all objects or elements being examined in a problem. We usually denote the universal set by the letter U, and it is usually uppercase U, so it's capital U. Okay, so we are going to do some of these problems here for you guys, so you have a model. By the way, I'm super impressed by your scores. You did very well, so keep up the good work. Do not slack, because often the students, after doing well on the first exam, they slack on the second. So don't let that be you. So keep striving for that excellence, and it will pay off in the end, because ideally you want to get to the final exam with a very good, solid score, so that if you don't do so well on the final, it's not a big deal, right? You can still get a good grade. So that's what I used to do when I was in college. I was always striving to get to the final in a very strong position, with a high average, so that I don't have to worry about the final exam. And I'm telling you, I'm gonna be honest with you, I never did very well on sometimes I did, but final exams, because I would have many, and like most of you will, during the same week, right? And sometimes more than one in a day, so it's hard to do well when everything is just taking place at the same time, right? Okay, so while I was talking, I hope that you got a chance to go over these definitions. So let's go ahead and begin. So let me get the papers here, the workbook problem. So I'll put it on the screen and then we'll read it and then we can take it from there. It says, example 1, let you be the patrons. Those are the supporters, right? The regular customers at IHOP. I'm not a regular customer of IHOP, but I know I went there with my boyfriend last year and we had an awesome breakfast. So I still have very good memories of IHOP. So I really like their food, their breakfast, right? That's what they're known for. Okay, so let C represent the set of patrons who are 12 or under, and let S represent the set of patrons who are 55 or over. Okay, so here we have to create the Venn diagrams that represents this situation, right? And so how are we gonna, let me show you. So I'm gonna actually work the problems for you and I'm gonna explain. This is a very cold morning. I'm recording this video during that the storm we had, the snowstorm. So today is the 15th of February, and as you know, the classes were canceled. So I said, well, what am I gonna do? I'm gonna start making these videos, right? So I have time to make the videos. Okay, so example 1, we normally start with a triangle, and this is gonna represent the universal set. So I'm gonna put a U there. So that's all the patrons at IHOP, all the regular customers. So okay, and then we're gonna have customers that are under, who are 12 or under. So I'm gonna call this, and it says sets. Okay, so this is set C. So I'm gonna put a Venn diagram. That's a circle right there. These are those who are under 12, and then you have those regular customers that are 55 or over. So then you have the customers 55 or over, and these are set S, right? Notice that they have to be separate. So these are called disjoint sets. Disjoint sets because they do not have elements in common. So no elements in common. So they have no elements in common because set C represents all the regular customers that are 12 or under, right? And S is the set of all the regular customers 55 or over. So as you can see, they have no elements in common. And then every other customer that goes to IHOP is going to be found outside of these, right? So people like myself, I am neither 55 or over, and I'm not under 12 or under, right? So I will be out here, right? I'm gonna be outside, but I'm still, I'm still that's if I'm still a regular customer of IHOP, right? I would be found there. Okay, so disjoint sets, no elements in common. So this is how you would set it up, right? So this is, remember, 5.3, all right? So these are disjoint sets. All right, so that's example 1. Now moving on to example 2. And let me put it on the screen so you can see it and we can read it together. Let U be the set of all the SPC students. Okay, so that would include you guys. Okay, if you're an SPC student. Okay, and all of you are because you're taking this class. So now M represents the set of SPC students who are taking math. Again, that would be you. And C represents the set of SPC students who are taking college algebra. So that wouldn't be you, right? So how do I set this up? Okay. Well, you're gonna have the rectangle for the universal set, right? That's you. That's all SPC students. And then we're gonna have those students taking math. That's a big set. I'm gonna put the M. And then inside that set, college algebra students, it's a smaller set, right? And you guys would be found outside of the C, right? But still in the M. Because you're taking 1332, so that's the liberal arts math, okay? And so we call this proper subsets. These are called proper subsets, okay? So that would be example 2. And so remember not to use small u for the universal set. It's normally a capital U. All right. So that's example 2. Okay, let's move on to example 3. Example 3. Let me get a clean sheet of paper here. Okay, example 3, and get everything organized. Lower the paper here. I have to look at the screen to make sure that you can see everything. Okay, so example 3. It says, let me put it on the screen. Let U be the set of natural numbers. And those are the counting numbers, 1, 2, 3, 4, 5. Let T represent the set of natural numbers less than 10. And let S represent the set of single-digit natural numbers. Okay. So let's see. Let me see what we're looking at. I need to go ahead and find the sets because, okay, so U is all the natural numbers. So this is the set of natural numbers. Natural numbers. What are these? These are the counting numbers. Okay, keeps going. This is an infinite set, right? And then it says T represents the set of natural numbers less than 10. So this is going to be 1, 2, 3, 4, 5, 6, 7, and 8. And then S is the set of single-digit natural numbers. Well, single-digit natural numbers, we have, oh, I'm missing here the 9, I'm sorry. The single-digit natural numbers are still going to be 1, 2, 3, 4, 5, 6, 7, 8, and 9 because 10 is a double-digit natural number, right? So you see how T is the same set as S. So to do the Venn diagram for that, you'll just need to do the universal set and then just do one set and say, well, T equals S because these are equal sets. Okay, those are equal sets. Okay, so that is number 3. And so let us now go to number 4. So number 4, it says, let U be the set of restaurant patrons. Okay, customers that go to restaurants. Let M represent the set of patrons that like Mexican food. Let C represent the set of patrons that like Chinese food. Okay, and so notice that you may have people that like both here, because we just know that we have the universal set, all those people that go to restaurants, right? That's all of us probably. Maybe some of you don't go to restaurants to eat, but usually most people are regularly visit restaurants. So we have Mexican people that like Mexican food, people that like Chinese, but we should also consider people that like both, like myself, right? I like both, and maybe you do like both as well. And so the red, if I let this one be the red here, this is those who like. So in red, I can write it here, red like both Mexican food and Chinese, right? And then the yellow, if I use yellow for this area here, the yellow can be Mexican only. They like Mexican only. Mexican food. And then if I had another color, I'm gonna have to use black here for the Chinese food only. So in black, like Chinese food only. And then outside, you still have the white area. They neither like Chinese nor Mexican. Okay, so that's the area in white over here. You have people that don't like Mexican and don't like Chinese, right? So yeah, that's basically what do we call this? These are sets with common elements. Okay, so sets with common elements. All right. So that is what we have for the first problems there. We're moving on to more examples here that I'm going to go through, and I'm going to be giving you some definitions, so be ready. This is not going to be a short lesson because there's a lot to cover here. So let us move on to the next, to example 5. Put this here. So example 5, you have, but it's not difficult, it's just I have to give you some definitions. So the definitions that we need is, let me write them here. Definitions, we need to know what is a complement of a set. So I'm gonna begin by let A be a set, and I'm gonna say non-empty set. Okay, so non-empty set. And so we have, and let A be a non-empty set, also let B be a non-empty set, because I'm gonna use these two sets to define some things. And so the first thing I'm gonna define is the complement of A. Okay, so suppose that these two sets are not empty. That means that they do have some elements. So what is the complement of A? The complement of A, now we're going to use A prime to denote the complement of A. A prime is a set. This is the set of all elements outside, that do not belong to, so outside of set A. In other words, all the elements that are in the universal set but that are not in A. So to be more specific, all the elements in the universal set that are not in A. Okay, so all the elements in the universal set that are not in A. That is a complement of A. Okay? Make sure you understand the notation. This is the notation that we're going to be using. A prime. Okay? Now, the intersection of two sets. The intersection of sets. This is A intersected with B. That's the notation. A intersected with B. This is the elements common to both A and B. So the elements found in both sets A and B. So that means that, what does that mean? The common elements. Right? The elements that they have in common. They must be both in both A and B. Common elements of A and B. Okay, so common elements of both A and B. Okay, so that's the intersection of A and B. That's the notation. Now the union of A and B, the union is all the elements in A, all the elements in B together. You put them together and you create a long list, you know, of everything in A. So the union, you want to say union of two sets. So we have the notation as A union B, put together all the elements in A plus all the elements of B, and omit, do not include repetition. So only once, if you see that, for example, the number 2 shows up in both A and B, right, you will include it once. You're not going to include it twice. Okay, so that's the union of two sets. Okay. Now we are going to go ahead and practice with some of these questions. So let's go ahead and look at number 5. So we're going to look at number 5. And so example 5, I'm going to use a different piece of paper here because I need to work the problem. Okay, so example 5. So we have the rectangle here, and then the circles, and then you have the universal set, and in red, let me put the elements. You have 1, 5, and 3, 6, 7, and 9, and then 4 and 8. And then we have set A here, and then set B, and then U, and outside here you have 2 and 10. And then we're going to answer some questions. Right, we're going to look at set A. For example, first one is set A. Well, you're going to list all the elements in A. So we have 1, 3, 5, 6, 7, and 9, right? All the elements in A. And then B, it says set of elements in A, but not in B. So make sure you're looking at the workbook. Okay, it's number 5, 5.3. Be looking at the workbook so you can understand what I'm saying here, because I can't be putting the paper here. Well, maybe you can be looking at this one. The set of elements in U but not in A, that's, oh, okay, B, we're doing B. Set of elements in A but not in B. So in A but not in B, right? So you're just looking at 1, 5, and 3 here. 1, 3, and 5 in order, right? And then C is the set of elements in U and all of U but not in A. Okay, so outside of A, it's gonna put us at 2, 4, 8, and 10, right? 2, 4, 8, and 10, because we want to be in U but not in A. Now, that's ABC. Now D says the set of elements in both A and B, so that's going to be right here, this area here. So 6, 7, and 9, right? Both in A and B in the intersection. And then E is, oh sorry, I should use this, the parentheses. E is a set of elements in B but not in A. So you want it to be in B but outside of A, so you only have 2, 4, and 8, right? And the set of elements in neither A nor B, so neither A nor B, so that's gonna be 2 and 10. Okay. Alright, so that's example 5. And let me see. Remember we talked about the empty set, so don't forget about the empty set. We're gonna have to answer some questions about the empty set here. I'm gonna do, let's do number 6. And so yeah, because all of these, they're not difficult, but I think you need to see them, so I need to work them for you. Okay, so that's number 5. So number 6, we have a set. Okay, this is the set, the universal set is given, and then we're given another set A and another set B. I recommend that you create the Venn diagram before you answer the question, so we're gonna do that. So we're gonna create the Venn diagram before we answer the question, so you please do that. That's gonna help you. You know you have 2 sets A and B, and they're gonna have some overlapping elements, right? And so you want to start from the inside out. Start from the inside out. So what are the elements that are in both sets A and B? You have 1, 5, and 8, right? Let me show you why that is, because you look at A, you have 1, 2, 5, 6, 8. And you look at B, 0, 1, 5, 7, 8, and 9. The only ones that are in both, you have 1, right? 1 is in both, so you put it there. 5 is in both, and 8 is in both. So that's this area, the intersection here. And then you do the same. You work now outside of the intersection. You want in A but not in B. So those are 2, 6, and 2 and 6, right? 2 and 6. Because you want in A but not in B, and then you want in B over here but not in A, so you get 0, 7, and 9. And then outside you have 3 and 4. Okay, so go ahead and create this one first, because that's gonna help you answer the questions. Once you do that, then everything else is gonna be really easy. So we do A. We have the complement is everything outside of A, so that's gonna include the 0, the 3, the 4, the 7, and the 9, right? 0, 3, 4, 7, and 9. You see how easy it is now to answer the questions. And then B prime is going to be outside of B, so it's going to be 2, 3, 4, and 6. And then C is the intersection. A intersected with B. A intersected with B is this area, right, where both have common elements, 1, 5, and 8. And then D is A union B. Remember, this is going to include all of the A elements, all of the B elements, but no repetition. So you're going to have 0, 1, 2, 5, 6, 7, 8, and 9. Notice that even though the 1 shows up both in A and in B, I'm not going to write it twice. Okay? And then we have something like, okay, A intersected with the empty set. This is like saying you're taking A together with the empty set. What elements do they have in common? Well, they don't have anything because the empty set is empty. So that's just going to be the empty set. Right? So whenever you're trying to intersect with the empty set, you're going to get the empty set because the only thing that they have in common is no elements. So that's just, they don't have anything in common. They don't have any common elements because the empty set doesn't have any elements. So the answer has to be the empty set. And then if you take B and you unite it with the empty set, it's like having a set and adding 0 to it. So you're still going to get B. Okay? All right. So let's move on to the next example. So I'm going to do the next one, and then I may ask you guys to do the, well, I may still just do it because these are important problems for your next test. So let's see. Example number 7. You have, it's the same Venn diagram we created because you have the same sets. So we have the same Venn diagram. We have 2, 6, and then we have 1, 5, 8 here. And then we get 0, 7, and 9, and 3 and 4. The same one because remember we have the same sets. And then it's asking for the union, right? So look inside. This is the union, but then there's prime. So that means complement of the union. That means that you have to be outside of the union. The union is all of that. So if you're outside of the union is all of A, all of B. So all of this is the union. But if you're outside of the union, then you're at 3, 4. Right? Make sure you understand that. So if I look at the union, if I were to draw the union, look, I would do this. If I were to draw the union, I would say all of it is the union, all of that. That's the union. But if I want to be outside of the union, that puts me out here, right? So the only elements are 3 and 4. So this is the union. All of the yellow is the union. If you're going to be outside, you're going to be here, right? Okay, now B, you get A prime intersected with B prime. What does that mean? Well, let's see. Let's take it one step at a time. A prime means you're outside of A. So that puts me all here and there. But then it says together with, so at the same time, B prime. Okay, so outside of A and outside of B, at the same time, you want to be outside of A and outside of B. The only place where that's going to give, what's going to happen is 3, 4. So it's the same as the previous set. Okay, once again, A prime intersected with B prime. This means, this intersection means, this means overlap. So they have an overlap, you know. And so the only place where they're going to be outside of A and outside of B at the same time is here, 3 and 4. Okay, so that's number 7. And number 8. I think you can do number 8 for practice. I'm going to let you do number 8 for practice so that this video is not too long. If you have a question, you can always send it to me, but I think I've given you enough already to show you how to do these problems. Okay, so I'm going to move on to the last part because I need to give you a definition. So let me give you a definition because I don't want to make the video too long. if I trying to avoid very long videos. Okay. So the definition of cardinality of what we know about cardinality, that's the number of distinct elements in a set. So the cardinality of, say you want to find the cardinality of a union. So you have this formula for the cardinality of the union of two sets. So you have, remember I use N for cardinality. So N of A union B is equal to, that's an N, the cardinality of A, so you take the cardinality of a set A plus the cardinality of a set B, and then you're going to subtract the cardinality of the intersection of A and B. This is a very important formula. You want to know this formula. It's really important. And we're going to use it to answer some questions. Okay? So make sure you understand. This is the cardinality of the union of A and B. So in other words, what is it saying? How many distinct elements are in the union? So that's what it says, you know. This means the number of distinct or different elements in the union of two sets. Okay, so let's read the first problem. I'll do the first one and I'll let you do the second one. It's the same thing. Okay, it says, actually let me do number 10 because that's harder. And then I'll let you do number 9, that's easier. So I'll do 10. In a survey of 200 registered voters, 96 people said that the economy was one of the top issues. So you wanna, that's a first set. So you can call it E. 97 people said that the national security was one of the top issues. You can call that set S, right? So you have already cardinality of E, which is 96, that think that the economy is a top issue. 97 people think that national security is a top issue, so about 50%. So N of S, cardinality of S is 97. And 29 people said that both were one of the top issues. So then you have the intersection of the two, 29. How many people in the survey thought the economy or national security was one of the top issues? You see the word or? That means union. Anytime you see the word, and let me just write that so you don't forget. So if you see the word or, you know, if you see the word or, make sure you use the union. For example, A, if you suppose you have A or B, right? A or B, what are you gonna write? You're gonna write A union B. Okay. If you have A and B, so let me make sure that this is, because this looks confusing. These should be like this, A or B. Same thing as A union B. If you see A and B, the word and, now you're gonna write A intersected with B. Okay? So if you see or, you use the union. If you see and, you use the intersection, the overlap. Alright, so let's set it up. It says, so remember E is for the economy. The number of people that think that the economy is a top issue. S is for national security. Number of people that think that national security is a top issue. The formula says that the cardinality of the union is equal to the cardinality of E plus the cardinality of S minus the cardinality of both E and S, right? So I know I have 96 people believe the economy plus 27 believe national, actually 97 believe national security is a top issue, and we know 29 said both. So then you just figure this out and you're gonna get the cardinality of the union. You're gonna get how many people thought that the economy or national security was a top issue, and you do the math and you're gonna get 164 people thought that the economy or the national security, so either one, right, is a top issue. I personally think that they're both just as important, so I would be in that category where, actually no, I would be here, both, thinking that they're both, they're just as important. Okay, both are one of the top issues for sure. So okay guys, that's it for this section 5.3. Like I said, I don't like to make it too long for you guys so that you stay focused on, because when I make them too long, I don't think that's a good idea unless it's needed, right? So this is section 5.3. I'm going to now rest a little and then make the video for 5.4, and I will see you in the next one. You take care. Have a blessed day. Bye bye.